From the Microsol Resources Tech Team, this is James Wong. Today we'll be presenting to you some known and unknown facts about memory and how to use it in Revit. We realize that a lot of you out there have a lot of memory questions and ways to optimize it for Revit. We hope to demystify and also dissect how Revit works with memory and optimize it for your firm's needs. So CPU in relationship to Revit. Revit software itself, without any files or projects open, does have a certain amount of overhead. The main application itself does not take advantage of multi-core multiprocessors. But there's something to note is that Revit rendering does take advantage of multi-core multiprocessors. So if you have a dual-core, quad-core, 4 processors, etc., you can actually take advantage of all those cores and processors in rendering. You can also set processor infinity or processor priority. This ensures that Revit gets its own dedicated core processor for maximum performance, and it doesn't share its processor with other processes, such as After Effects if you have Photoshop open or Outlook open. Also, we have something called BIM services. We have Revit model best practices. We can actually help to improve your model performance. So ask us about that if you have a given moment. Also, we have to have a general understanding of what RAM actually is and understand that not all RAM chips are created equal. On one end of the spectrum, you have the general DDR2 800 as well as the very high performance DDR3 1600 for fast RAM. There's also a capacity issue. Would you want one very large RAM chip or many multiple smaller RAM chips of faster speed? Also understand that physical RAM versus virtual RAM, paging file or virtual memory, they're actually considered the same thing. Physical RAM is actually made of the chips itself installed on your workstation, whereas virtual RAM, paging files, or swap files, they're actually allocated by your operating system. It allows the physical address space to be non-contiguous. It extends the amount of physical RAM available to your system, but keep in mind that the newer high-performance machines doesn't need any paging files itself. So if you want to load your 64-bit machine with 32 gigs of RAM, that's preferred. There are some misconceptions on how much RAM Revit can actually handle. I've heard people say that Revit can only use 3 gigabytes. This is not true. If you install the 64 native version of Revit, it is native 64-bit software, so the total virtual address space can be as much as 16 terabytes. That's terabyte, guys. Basically, it can eat up all the RAM you give it. Windows typically allocates 1.5 times the amount of RAM installed. If you want to manage your own RAM, go to System Properties. But as I mentioned before, newer systems with lots of RAM typically don't even need virtual memory configured. So give it more RAM and Revit will be happy. In Task Manager, which I'm sure you guys are very familiar with, you can see the different applications that are currently running on your system. If you jump over to the next tab, you can see the different processes as well as the CPU usage per process as well as the memory usage. The Performance tab is particularly useful as if you have different cores on your system, it will actually tell you the current CPU usage per core as well as the physical memory usage that you have on your system right now. If you want more detailed analysis on your workstation, you want to click on the Resource Monitor button. And this will actually bring up Resource Monitor. I actually have it configured, so to jump up into the Memory tab, you can see here that the physical memory allocations in this bar graph, and how much memory you have standby, how much memory you have free, and how much memory is currently in use. You can see that these are listed per process. You can sort these as needed. There are different types of memory here. There's a commit, which is the amount of virtual memory reserved by the OS for the process in kilobytes. The working set, which is the amount of physical memory currently in use by the process, which is in kilobytes again. The shareable memory, it's the amount of physical memory in use by the process that can be shared with different processes. So if it doesn't need, if it's allocated a certain amount and it needs less, that memory can actually be given to another process. The private, which is it's the amount of physical memory in use by the process that cannot be shared. For example, I'm going to scroll down here and look for Revit, and you can see here that Revit is actually commit set is 277 megabytes of RAM right now. But its private RAM is actually 229 megabytes. Its shareable RAM is 136 megabytes. What that means is that this 136 megabytes that it's in the shareable memory, this can be given to any other process that's running or will be running. So if it doesn't need the memory, it will actually give it back to the OS. You can see also on the right hand side I have a hard faults per second chart or an active graph. You want to minimize the amount of hard faults on your system by having sufficient memory resources at any given time. So now that you know there's a general overhead just to start Revit, you need to also allocate some memory for having your Revit projects open. Figuring how much RAM your projects will need, you can take a formula derived from some Revit AOTC courseware. So you take your model size in Windows Explorer, you multiply that by 20, and you take your linked file sizes and you multiply that by 20, and that is the active RAM you need. Of course, this is a very general formula. So if you have a 100 megabyte file and you have a 40 megabyte structural model and two CAD files at 1 megabyte each, you follow this little formula. And this is the amount of RAM that it will actually take just to open your model, not the overhead it needs for the software or the overhead that you have for your operating system, as well as any currently running applications such as Outlook or chat or etc. 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 For all intents and purposes, of course, go with a 64-bit machine and put as much RAM as possible. So I hope everybody enjoyed the quick little video. I know there are a lot of topics that we covered today, but they're all vital for successful implementation. Gladly, there are a lot of documentation available, so please be sure to check those out as well. Any questions or comments? Feel free to shoot me an email. I also have a blog, thejame@wordpress.com. There's also a YouTube channel. Please check out our upcoming events at the microsolresources.com website. All right, talk to you soon.